All right, let's get started. Lecture number 22. This will be our final formal lecture. Okay, so concrete retrofitting technologies. Okay, we'll talk about how to repair reinforced concrete structures. Okay, so this lecture is after a book which is called Concrete Repair and Maintenance, illustrated by P.H. Amos. Okay. There are different type of structural repair. Okay. The first one is surface repair. Repair spalling due to corrosion of reinforcement, delamination. We'll study how to select the materials, okay, how to prepare the surface, and how to place the repair materials. Okay. And this is the focus for this lecture. The second one is strengthening and stabilization. Okay, for example, beam and column, we want to increase the capacity. Okay, or we want to stabilize the connection between column and beams. Okay, this is the structure strengthening, which is not focused for this class. Okay, the third one is how to protect members from corrosion, freeze-thaw damage using different type of coating, polymer impregnation. We will touch this part a little bit. It's not a focus, but we'll talk a little bit about this. So we will focus on surface repair. Before we do that, we need to evaluate the condition of existing concrete structures. Okay, we can use destructive testing or non-destructive testing as we discussed before. For example, GPR or ultrasound to see, the delamination inside the structure. And for surface repair, we need to analyze, the conditions, okay, and then get some strategies to repair, and then we can design the repair, okay, including selection of the materials based on material requirements and how much load and how much shrinkage the material may experience. Okay, and then we select the type of material to use. After that, we're gonna prepare the repair surface. Okay, we also talk about repair for rebar corrosion, okay, or bonding repair. Okay, and finally we'll talk about the placement techniques depending on the size of the job or property of the repair material such as viscosity. We may select different type of placement techniques. The first one is we analyze, we give strategies, and we design repair, okay, which is based on the structure need. Okay, so we need to analyze all the possible stresses in the repair materials. This is very, very important, and sometimes not very easy to do. Okay. We need to analyze the stresses at the interface between the repair materials and the existing material. We also need to consider the volumetric change due to dry shrinkage, because dry shrinkage of new materials will be more compared to existing old structures. Most of the shrinkage will occur in the first several months after casting. Okay, and sometimes we even need to recreate the original load distribution. Okay, to provide the full load relief using temporary shoring and jacking. Okay, we'll give an example of that later. Right. So analyze the forces, the loading, and also the internal stress due to shrinkage, for example. So this picture showing us the stresses may coming from thermal loading. The sign will increase the temperature on the outside, so we have temperature gradient, so that will have some thermal loading on the structure. Live load, dead load, okay, moisture gradient, impact load, okay, and the internal load, the load transfer from beam to columns and to the foundation, okay, and also of course shrinkage load. So there are potentially many different type of stresses could acting on repair and existing materials, okay, including again internal structure forces, external static concentrated loads, the moving load, thermal expansion, contraction due to temperature gradient, due to dry shrinkage, and other type of shrinkage. Performance requirements. Okay, we also need to study the type of load the repairer need to carry. Okay, for example, this is surface repair, okay, trying to address deep spalling, okay, and repair of balcony reading attachment. Okay, so we have a live load acting on the rail. Okay, okay, and the surface repair need to carry the structure load, for example, from the live load, and also transfer the load to the existing structure. Okay, and also we need to think about how to protect the rebar from further corrosion. Okay, after repair existing corrosion, if there's any, and the load transfer. So here shows an example of the challenge of placing load into repairs. Okay, so this is a reinforced concrete column. Okay, and this part of the concrete and rebar is need to be repaired. Okay, so if we just chip off the old concrete and repair the rebar, okay, then the higher stress level will generate in the areas where the load are not redistributed to the repair. Okay, so and also between the repair and existing materials, we have dry shrinkage because again, the repair materials have more shrinkage at early age. Okay, and also we have shear stress developed in the bonding between the existing and a new concrete. Okay, so these all are things we need to worry about. So one of the ways to do that is we use temporary shoring to release the internal stress before we apply any type of repair. Okay, and then after repair materials hardens, then we release the force. Okay, so then we have a better distribution of the internal force. So for this type of repair, the first step is we need to remove the load from member by using shoring or jacking before repair. Okay, so basically the member is almost free of internal stress. Okay, then we can use low dry shrinkage and low creep materials to do the repair. Okay, and also the E value, the modulus of elasticity of the repair materials and the existing substrate should be matched to each other. Okay. The ideal repair material should, have these functions. You need to fill the repair cavities completely, okay, and do not shrink or shrink very little. Okay. That is because old substrate, old concrete does not really shrink as much. Okay. Okay. And the ideal repair material should behave the same way as the substrate when subjected to low temperature and moisture change. Okay, so selecting an ideal material is it's very hard, but it's a job of compromise into balance between what we have in hand and what is required for the repair job. So material requirement should also consider user performance requirements. This is from the side of owner. Okay, for example, if the repair should be visible or hidden. Okay, how fast you want to finish the repair job, the turnaround time, expected life of repair. Okay, how long you want the repair to last, and also the maintenance intervals. So how often do you want to do the repair? Okay. And also service and exposure conditions. Okay, like load carrying requirements, including both the live and dead load. Okay. If there's any chemical exposure to the repair materials, UV exposure, okay. Moisture and temperature requirements. Okay, so all these conditions need to be considered. Placement conditions. Okay, so the wind, temperature, moisture, loading, okay, around the structures. Okay, placement techniques, okay, which is controlled by flowability requirement for the repair materials. How fast you want the repair material to setting time. Okay, and geometric configuration of repair. Okay. The surface area, how large you want to do the repair, the thickness. Okay, so these two control how much material is needed and control the cost. Some of the repair materials are very expensive, such as polymer. Okay. Size of the rebar, spacing of the rebar, that may affect us to choose the flowability of the repair materials. So many material requirements we need to consider. And then we need to establish material properties. Okay, so here is a table showing us the load carrying properties. Okay, and what is the goal or the performance requirement? What is the result if raw materials is selected? What other property of the materials are important for that performance, and what things we need to avoid here? Okay, we can just look some of the example. If the goal is to bond to the substrate, like in this case, okay, if the raw materials is selected, we may lose of bond or delamination due to high dry shrinkage, for example. Okay, so the property we need to look for is, the tensile stress in the bonding between the old and new materials, and also we should reduce the internal stress. Okay, and we should avoid high internal stress caused by thermal incompatibility. That means the coefficient of thermal expansion of the materials are different. So when we have a temperature change, we may have stress developed in the bonding area. And also, if the repair material has too much dry shrinkage, it may also result in these problems. Okay, and we have some other goals, situations, to consider. And this table from the book showing us the surface exposure properties. Okay. Again, what is the goal? Okay. What happens if the raw material is selected, and what properties are important for that performance, and what we need to avoid. Okay. For temperature change, we need to match the coefficient of thermal expansion between the new and existing materials. Okay. So the stress due to temperature change will be minimal. Okay. Let's just pick some other things to look at. Okay, so UV exposure, for example, that is due to mostly sunlight. Okay, exposed to UV exposure may degrade the repair materials, especially for polymer. Okay, so we need to choose the materials for high UV resistance. Okay, and you can just look at the remaining properties. This table shows us the goals, okay, from external load and properties. Okay, for example, if we have moving liquid, then we need to worry about erosion on the surface. Okay, so we need to choose high density, higher strength, okay, repair materials to increase the resistance to corrosion, to erosion. Sorry. Okay, and also for if the concrete repair materials will be in touch with vehicle wheels, so we need to choose high density, high strength materials. Okay. For impact contacts, we also need to choose higher strength, tensile strength, bonding strength, okay, and so on. All right. Constructability, appearance properties. Okay, so this looking including turnaround time. Okay, so how fast you want to do the repair. Requirement for the flowability. Okay, depending on the size of the job, location of the job. For example, if you do an overhead repair, the viscosity of the repair material need to be high, so it will not fall off. Okay. This is the properties we need to look for, and this is the things we need to avoid. Okay. Okay. So if cracking is a concern, we need to look for materials with low dry shrinkage, okay, or even use a flexible surface membrane to enhance the resistance to cracking. Smaller change in temperature, so we have a lower potential for thermal cracking, okay, or reduce the surface water loss, so we can reduce the dry shrinkage. Okay. So material requirement should also consider volumetric change due to temperature change. Okay. So this is controlled by coefficient of thermal expansion. Due to loading, that is controlled by the strength and the modulus of elasticity of the materials. Okay. Volume change due to shrinkage. Okay. Again, because existing material does not shrink as much as new materials, so that's potential problems. And also creep. Okay, so existing material does not creep as much as new materials. Okay. So most of the creep and the shrinkage occurs in the first several months. Okay. And the volume change due to this effect is one of the most important things we need to consider. Okay. So we need to consider all these materials requirements mentioned above, and then we should choose the right materials to use. Okay. So the next table shows us what are the potential materials can be used for repair. Okay. What are the major ingredients for these materials, and what are the requirements for application. Okay. For example, we can use Portland cement mortar or concrete. Okay. We know the major ingredients and what are the limitations for the thickness, the temperature during installation, and how long we need to cure the materials. Okay. So silica modified Portland cement concrete. So that's cement with silica fuel. Latex modified Portland cement concrete. We discussed that before. We can modify the performance of this latex modified concrete. Magnesium phosphate cement concrete, that's a special type of concrete with a different set of chemical reaction. It can also be used for repair purpose. Okay. Pre-placed aggregate concrete, that's a special situation when we place the aggregate in the formwork and then we inject the mortar afterwards. Epoxy mortar with no coarse aggregate. MMV concrete, this is also belong to polymer concrete, and shotcrete. Okay, so all these different materials, they have a different type of application to use. And these are the same materials, but property of these materials. For example, how much drain shrinkage this material will have. Okay. What is the coefficient of thermal expansion? Okay. So very useful information here. And what are the strengths at different age? The E value of these materials, the permeability, okay. The freeze-thaw resistance, non-sag quality means, if the viscosity is high, then the material will not sag. So that means high viscosity. Exothermal means how much heat these materials can generate. So based on the requirements, we select the right type of repair materials to use. Okay. Then the next step is to prepare the surface. Okay, the surface of the old concrete, okay, which will be the bond area between the new and existing materials. The general procedure is first we need to use non-destructive testing, visual inspection to find out the areas to be repaired. Okay. And then we need to remove the deteriorated concrete using different methods. Okay. Then we need to repair the boundary, prepare the repair boundary to prevent failure edge conditions. Okay. We'll talk about that in a moment. Then clean the surface of exposed rebar, if there's any, and the concrete, exposed sound concrete. Okay, get rid of all the damaged materials before we apply the new materials. All right. So here shows how to repair a corroded rebar in the concrete. Okay, so basically we need to clean out the rust. Okay, so this is some of the requirement. All exposed steel and concrete surface need to be cleaned to remove corrosion and other bond inhibiting materials. So get rid of all the rust, get rid of all the damaged concrete, and also some requirement for example, spacing. So minimum 3/4 of inch clearance underneath the bar. Okay. And then we should decide the layout for repair materials. The layout should be made as simple as possible. Okay, so for a couple of reasons. One, it is easy to apply. Okay, so this is the boundary of loose and delaminated concrete. So we better use a square, a rectangular layout. Okay, as simple as possible. Okay, the reason for that is one, it is easier to apply for a simple layout. The second reason is when we have a simple layout, we will have less stress concentration at the corners. Okay, for example, in this layout, even though we may save some of the repair materials compared to the one on the right, okay, but we have so many corners here and there, and that corners will generate stress concentration. When materials shrink, for example, or we have temperature change, so the repair materials may crack, have more crack compared with a simple layout. So these are the major reasons. Easy to apply and less stress concentration. Okay. So that's how we decide the layout, and then we need to prepare the surface. Okay. We need to remove the damaged concrete. Depending on how deep the repair need to be, for partial depths, we can use this method, such as pneumatic chipping hammer, okay, high pressure water, pneumatic scrubber, okay, and so on. For full depths, we can use pneumatic breaker, okay, hydro demolition, okay, a pneumatic mounted breaker, okay, to demolish the damaged concrete. And then if there's any steel reinforcement corroded, we also need to repair and do some protection if needed. The general procedure is we need to remove the concrete around the full diameter of the rebar. Okay, so that is important. Okay. And also remove the rust and heavy oxide to ensure good bonding between the rebar and new repair materials. Okay. We need to repair or replace damaged rebar. Okay. Depending on how much rebar is damaged, sometimes we need to cut off the rebar and apply a new one. Okay. And sometimes we also need to apply special coating if required, such as galvanized zinc or polymer on the surface of the rebar. Okay. So here shows the rebar protection method. Okay. We can use epoxy coating. The purpose for that is to insulate. Okay. So isolate the rebar, the steel from oxygen and water by using epoxy. Okay. But it must fully cover the entire rebar. Okay. If the epoxy is damaged in some area, then the corrosion may start again. So this is not very easy to achieve for fully cover the entire rebar. Okay. So cathodic protection or sacrificial anode can also be used by attaching aluminum or zinc, or using galvanized thin layers of zinc on the surface of rebar can also be used. Okay, so this is called cathodic protection. Or we can use impressed current, okay, such as using a battery to send a current to reverse the corrosion current flow. Okay. You can also use alkali slurry coating. Okay, so alkali, the high pH level of alkali slurry will help generate the protective thin film on the surface of the rebar. Okay, so these are some of the rebar protection methods we can use. Professor Lloyd Hihara from mechanical engineering, he's the, I think he's the advisor for Song Ya, right? Okay, so yeah, Professor Hihara is expert on corrosion. Okay, and right now we are working on the project, which is to retrofit a Navy reinforced concrete structure. So we are working on how to protect the corroded rebar and how to repair the damaged concrete in that Navy structure. Okay. And as we can see from here, here shows some of the methods we can protect the rebar from corrosion, including alkali protection. We can use alkali slurry coated on the surface. Okay. Or we can use cathodic protection by applying a zinc layer, galvanized bar. Okay, so the zinc will sacrifice itself and the steel will be protected. Okay. And here shows we can use a battery. This is the surface installed anode connected to bar with impressed current. So that will change the flow direction of electrical current. Okay, so when we talk about corrosion of reinforced concrete, we talk about the half cell potential. The chemical reaction occurs on the anode and the cathode area. So using the battery, we can reverse the flow of the current. Okay. So we can reduce the corrosion. Also epoxy. Okay, when we use epoxy, remember I need to cover the whole length of the rebar, which is not easy to achieve sometimes. All right. So bonding between the repair material to existing concrete, the key to do that is we need to get a clean and sound substrate. Okay. We can also roughen the surface of the substrate to ensure a good mechanical bonding or interlock. Okay. Also open the pore structure of the substrate by using high pressure water, okay, for example. Okay. Or we need to apply the pressure to facilitate the contacts between the repair material and the existing concrete. Okay. So to do that, the general procedure is here. Okay. Use chipper, hammer to roughen existing concrete. So we have a clean and sound condition. Okay. We should also use hydroblasting vacuum to open the pore structure on substrate. Okay. And before we apply the repair materials, we need to moist the surface of the substrate to saturate the surface dry condition. Okay. The reason for that is to make sure the water will not be sucked from the existing materials from the new materials, so reduce the drying shrinkage. And then we apply the repair materials to achieve the intimate contacts, to ensure good contacts to the substrate by using high pressure and or high velocity impacts in the case of shotcrete, for example. Then we can also use a pull-off test to check the bonding if we want. And finally, the placement method. Okay, after select the materials, after prepare the substrate. Okay, so we need to place the new materials. One of the methods is dry pack. Okay, so very simple. We set up the formwork. Okay, and then we put the repair material in, and we can use hammer and hardwood to compact repair materials. Okay. This is for small cavities when the mortar or concrete has a very low slump. So we can use this method. Yeah. For large job, we can set up a formwork like this. Okay. And then we cast in place the concrete, just like for any type of new construction. We pour the concrete in, and then we vibrate the concrete. Okay. We can also use self-consolidating concrete, for example, to eliminate the requirement for vibration. Okay. But this is the most commonly used method for the repair, form and cast in place. This method is called form and pump. This is a relatively new method, which use pressure to consolidate the materials. Right. So we also need to set up a formwork. Okay, the formwork will confine repair cavities. Okay, and then we pump the repair materials into the cavities. The high pressure from the pump will help consolidate the materials. Okay, but of course, the formwork need to be fully sealed, so we can apply the pressure without leaking. This is another method called the grottate placed aggregate. Okay. So in this method, the aggregate was placed into the formwork first. Okay. We set up the formwork, we place the aggregate, okay. And then the forms are fitted with pipe. Okay. And then we use a flowable grout to pump the repair materials into the cavities. Okay, so also we need to seal the formwork. This grouted pre-placed aggregate has lower shrinkage because in this approach we can put a lot of aggregate in the voids, so we can reduce the amount of cement paste in the repair, because shrinkage only occurs in cement paste. So when we increase the amount of aggregate, we can actually reduce the shrinkage. Okay, so that's one method to reduce the shrinkage of new repair materials. Okay. Okay. This is another method of placement called dry mix shotcrete. Okay. We discussed shotcrete before, which can use the pump to pump the concrete through a nozzle with very high speed. Okay. So dry mix concrete, the procedure shows here, the blended dry repair materials is in the shotcreting machine. The water is added right around the nozzle area. Okay, so the water is added right before the concrete was shut off the nozzle. Okay, here said the shrinkage may be high, and the entrapped air behind the rebar due to rebounding. Okay, so and also lost some of the aggregate. Okay, so these are some of the potential problems for this method. We also have wet mix shotcrete, where we mix water with the dry materials, then we pump the concrete through the nozzle. Okay, they have the same potential problem, including high shrinkage and entrapped air behind the rebar. Okay. Imagine we pump the concrete at high speed. So behind this rebar, it may not be fully wrapped by the repair materials. Okay. So yeah, this is something we need to be aware of. Okay. Okay. All right. This is another method for large-scale repair, full depth repair. When the damage is extensive, we can use low shrinkage concrete to do the full depth repair, okay, like this in the repair of slab, reinforced concrete slab. So we do the demolition, we set up the formwork, and then we just pour the concrete and vibrate the concrete as we will do for the new construction. Okay. Make sure to use low shrinkage concrete, otherwise we may have a debonding due to a higher dry shrinkage of the repair materials. Okay. If it's not full depth repair, only for the surface, we may do the overlay repair. Okay, for bridge and parking deck, okay. We can use latex modified concrete, MMC. We can use polymer concrete or use normal concrete. Okay. The reason for that is because latex modified concrete and polymer concrete are more expensive. So normally we do not do this for full depth repair like this. Okay, so only on the surface. Okay. The durability is very high. The strength is super high. Also, the concrete has high abrasion resistance due to high strength. Okay, but polymer may be suspected to a UV degradation. That's one thing we may worry about. And for some small repair job overhead, we can use hand applied using non-stack materials, which is a material with very high viscosity. We apply on overhead, it will not drop off due to low viscosity. Okay. We can do that for vertical surface overhead locations. Okay, so make sure you apply enough force to ensure good bonding, okay, and to ensure good wrap up of the reinforcement. Okay, so this is the most basic method repair job for small repair job. All right, so that's the end for our final formal lecture. Okay, next class, Tuesday and Thursday, will be our presentation, as I remember. So I remember